Okay, some more notes on section 4.3, and this is, again, just an example of the first derivative test, and we've done these before back in section 4.2, so this won't be totally new. Okay, so again, this is my function. This is an example. We want to find the local extreme on this for this function here. So first of all, we take a look at the derivative. So f prime of x equals 3x squared minus 12. And remember, we're only interested in places where this is going to be either equal to 0 or undefined, because those will be our critical numbers. So f prime equals 0 or f prime is undefined. Well, this is just a nice parabola, so that's not going to be an issue, so it's not going to be undefined. So where would be equal to 0? So we can factor the 3 out, and we can say 3 times x squared minus 4 equals 0, so x squared minus 4 equals 0 if we divide both sides by 3, and then we just say x squared equals 4, so x equals plus or minus 2. So those would be our two critical numbers. So we draw this line, for our first derivative test, and this will pretty much be a way of dealing with it, and you'll be responsible for all this. Okay, so there's a line. We'll mark that f prime. I'll be careful that you label it. And we'll put our critical numbers in, so this would be negative 2 and positive 2. Okay? And then we just check the values to see where it's positive or negative, and it's not going to change. Now, again, if we look at this, this is a cubic. If you kind of remember from your graphing, cubic's going to start, it's going to be modeled by y equals x cubed. Now this might have some dips in it, so it's going to start lower left and upper right. That's our end behavior. So it could look something like this. Hope you can see that, okay? Lower left, and it's going to go to upper right. Okay? Something like that. Now it may not have a dip. It could be relatively flat. It could be constantly increasing. There's all kinds of variations on this depending on the actual function. So let's get some idea of what's happening here. And this would really help us when we're sketching the curve, if we're going to try to sketch the curve, and we'll do that a little bit later. Okay, so let's try a value. Let's try negative 3, because that's smaller. So f prime, we could try f prime of negative 3 and see what that is. So if I put negative 3 in here, I could go all the way up to here. Negative 3 squared is 9. 3 times 9 is positive 27. So that's going to be positive. It's going to be positive all this area. Again, that's my slope. And then if I put like 0, 0 is a nice one in here, so I can try f prime of 0. I'm going to get negative. And then if I put positive 3, I'd get the same thing because it's an even function, so this would be positive. So this is easy to work out. And then remember, we talked about drawing these little arrows so we see what's going on. So basically my slope is positive, so my function is increasing till I get to negative 2, then decreasing till I get to positive 2, and then increasing there on out. So this is the slope, so it kind of looks like this: increasing, decreasing, increasing. So it looks like we've got a relative maximum at negative 2, because my slope is changing from positive to negative, and a relative minimum at x equals positive 2, because my slope is changing from negative to positive, just like it said over in theorem 4. So we do have to write this out, and they actually wanted the values, so we need the actual points, or the actual vertical position. So we know when x is equal to negative 2, what is f of x, or what's f of negative 2? So we have to put that into our original function. And if I look at this, negative 2 squared is negative 8. Negative 2 times 12 is positive 24, and then negative 5. And that looks like that's going to be negative 13 plus 24. That looks like that's going to be 11. Okay? So I can say that that's 11 over here. And this is what's happening, so I can say I have a relative, so we have to kind of write it out, and this is going to be definitely a statement that you have to write out. So we can say there is a relative maximum at, and sometimes we just want the x at x equals 2, but here we actually have we want the actual value, so this would be at the point -2, 11, and this would actually be the maximum value, and this would be where it happens. So this is the x, and this is the f of x or the y. Okay, there's a relative maximum at -2, 11, or at x equals 2, the relative maximum is 11. Because, and you have to write this out, don't have to write the because, the derivative f prime of x changes from positive to negative. There. At that point. Okay? And that kind of conforms to what they're saying in Theorem 4. Again, if you look on page 205, it says at critical point C, if f prime changes from positive to negative at C, then f has a local maximum value at C. So they're basically stating the theorem. Okay? They're just saying that we meet all those qualifications. All right? Now let's check the other one. Let's see, find our value. So when x equals 2, what's f of x or f of 2 equals? And then I've got to put 2 in here. So 2 cubed is 8. And then -2 times -12 is positive. Oh, sorry, negative, excuse me, negative 24. -12 times +2 is -24, and then -5, and that's going to be, well, that's going to be -16, 8, -24 is -16, and -5 is -21. So I got -21 there. Okay, so we can say over here there is a get this up here a little bit so you can see this. There is a relative minimum at my point, and my point would be 2, -21, and again this is the x and this is the value. So at x equals 2, the actual minimum value is f of x or -21 because what? F prime of x changes from negative, you can see this negative to positive, to positive. There. Okay? All right, so that's what we got. There's a good example of how to use the first derivative test, and you have to write all this stuff down, and we'll have some quizzes, and all these are going to be worth points. There's a lot of points to these problems. Okay, there can be an awful lot of points to these problems. Also, we talked earlier about the interval. You can see that it's increasing on this interval, decreasing on this interval, and increasing on that interval, which is some of the things we talked about in the last section. So there's a lot to this. So you can describe a lot of things going on with this simple little cubic function. Okay, hope that helps.